Okay, students. Another concept in atomic structure which we are going to discuss is photoelectric effect. What happens in this effect that here electricity is produced due to photons. That's why the term or the word comes photoelectric effect. What happens here? Here we choose a metal which can lose electrons very easily. Means its ionization potential should be very low. One such metal is cesium, right? As you know, in a first group we have got almost at the bottom which is the one which is the non-radioactive. After that francium comes which becomes radioactive. So although the IP means ionization potential of cesium is higher than francium, but still cesium is used mostly in place of francium, right? Because being radioactive, francium will not be able to do that work, and it will be hazardous also for the person who is doing experiments with francium. So to avoid all this, we use cesium, and actually nowadays technologically we have become more advanced, so alloys are being used, right? See, anyhow, now we take the metal here. For example, we have taken a cesium plate. This is cesium plate here. Now photons of a particular wavelength are made to fall on this. This is radiations here we have got, and these radiations have got sufficient energy so that when they collide with the electron will gain that energy, will absorb that energy will be transferred to the electron, and electron will come out of the atom after absorbing that, right? This is how we decide the wavelength or frequency of the incident radiation. The minimum energy required to eject out the electron for the metal is known as threshold energy. This is called as threshold energy, and this threshold energy is given as E equal to h nu, right? Usually we symbolize them by E naught, and this is called threshold frequency. Nu naught here is called as threshold frequency. This is threshold energy. Again we are saying the minimum energy required to eject out the electron from the metal is known as threshold energy. Now this is the minimum frequency which must be given to the metal so that electron will come out of the atom. This is minimum frequency, remember this part. Same formula we can put like E equal to hc by lambda naught, and this lambda naught here becomes the maximum wavelength which can eject out the electron from the surface of the metal, right? Remember this part. This is minimum frequency, while this one is maximum wavelength, because they are inversely proportional to each other. You can see if this is more, this has got to be less, right? Now what happens that if these radiations have got sufficient energy to eject out the electron from the metal, they collide with the metal atoms. Out of them electron will be there inside them. These electrons absorb the energy, and that electrons come out of the metal here like this. If the energy given to the metal by the radiations is exactly equal to threshold energy, then the electron comes out of the metal with zero kinetic energy, because whatever energy you are providing to the metal, the same is consumed by the electron to come out of the atom. Now understand one thing, if we put a metal plate here which is given positive charge, right, and again we connect it back to here, metal here like this, then what is going to happen that because of being positively charged, these electrons are going to get attracted towards the positive charge. As you know, electron is negative charge, so these electrons start moving towards positive charge plate. Now these electrons reach here potential difference is generated, these electrons come back again, and in this manner a circular loop is formed due to which current flow starts. If you put some instrument here, like we put a bulb here, simple electricity bulb here, if we put like this, then the bulb will start glowing like this. Got it? So here due to photons electricity is being produced, that's why this is called as photoelectric effect. Now understand one more thing. This is the case when the energy provided to the electron is exactly equal to threshold energy. if we provide greater amount of energy, which usually is done, we provide higher amount of energy so that the chances of electrons coming out of the atom will be more. Okay. So if higher amount of energy is provided to the electron than threshold energy, then electron consumes threshold energy to come out of the atom, and the remaining energy converts into kinetic energy. Got it? With that much kinetic energy, electron comes out of the atom. Now, this can be given in form of the formula as that kinetic energy equal to total energy given. This is total energy given to the electron minus threshold energy, like this. If total energy given we represent by the formula h nu, then this becomes h nu minus h nu naught, and this will be equal to kinetic energy of the electron, which can be given as half mv square. Here m will be mass of the electron, v will be the velocity with which electron will come out when it has been given h nu amount of energy, which is in excess of h nu naught. From here you can understand, if h nu is equal to h nu naught, the net amount of energy with which it will come out will become 0. Right? This is the case here. There are a lot of effects of photoelectric factor, actually lot of applications of photoelectric factor. One of the most important one being this is used in space shuttles. See, in space there is nothing which can provide energy for the space shuttles to run, for the rockets to run. Actually, fuel in rocket you can fill up to certain time, but space stations we have got, space shuttles we have got. What they do, that the surface, the outer surface of the space shuttle is covered with photoelectric cells. Now radiations are plenty in the space, so when radiations fall on that surface, it keeps on producing energy, which is used in form of electricity, and electricity is used for everything and anything in space shuttles. Right? So this is photoelectric effect here, which you understood.